DraftScience video, physics. So kind of two subjects, I think. First something on gravity, and then something on the quantum two-slit thing, I suppose. So anyway, I was talking to French-Swiss guy, and he had pointed out that he had this problem with the way I was metaphoring this idea of a photonic pressure creating gravity. And pressure is probably the wrong word to use, because although it seems like a good word to describe something that is encompassing, all directions. Most ways we associate the word pressure is usually in a medium. There's a medium creating the pressure. The medium fills in voids. So if there was two objects, there would be no way for them to shadow pressure, because the pressure would move around any voids between them. So there would be a transfer of the pressure through the medium. And the argument being made with photons is that they don't interact with each other. Photons aren't a medium, or they're gravitons. The photons that create gravity, let us say, are even regular photons. There's no evidence that I know of where you can collide photons into each other, where you can actually make photons interact with each other. They don't like each other. They only do this kinetic thing, this invisible interactions. Transparent interactions? Yeah, I don't know what the right word would be to use. So anyway, but they only interact with photons or electrons. I'm saying electrons are just photons, but in a different structure, and they can interact with those photons because those photons are locked next to each other. So that's a whole different subject, though. But free photons won't interact with free photons in a way that we can observe or see the evidence of the interaction. Something like that. So anyway, this pressure that's creating gravity is made of these photons that are moving in straight lines, and they have no personal momentum that they exchange with something else. They have a direction, and their direction can be changed, but other than that, they perpetually move throughout the universe forever, theoretically, and that's all they do. And they just keep bouncing off of things in a frictionless way, in a way where there's no transfer of anything called energy. There's just a transfer of direction. Okay, so back to the swimming fish metaphor, the school of fish metaphor. The rule is the fish don't hit each other. So whatever happens to the fish, it just happens that they change direction. The school swims in patterns, then it doesn't go anywhere, and we think it's got potential energy, and then when it's swimming in a direction, all the fish are going one way. We think of that as kinetic, but the two states are actually identical. There's no difference in the energy level in any real way. It's the same fish, they're just swimming in the same direction. Yeah, so the pressure doesn't fill in. That's why it can create the shadow. So that's why it's probably wrong for me to use photonic pressure as a phrase. I like the idea that you can get the sense of it pushing from all sides to create orbits and all this kind of stuff. So that sense of the idea that it's coming from all directions, but it doesn't do it like all other pressure that we know of, because the rule is it's photons, and photons aren't a medium. They don't collide with each other, and so they have to collide with matter. They have to collide with an electron or atom, fundamentally. So that would be the distinction. That's why there's no filling in. Okay, the shadow effect happens because the photons can't collide with each other and push more photons between two objects. So if the two objects are shadowing each other, there's nothing to fill in the shadow and to change the pressure difference. But there's more photons on this side of the object than on the inside, and that's why it moves in that direction. But that's another one of these things where I'll give the wrong impression that the movement is because the photons are pushing it. And they're not really pushing it, they're just changing the direction of the fish. So it's as if two schools of fish collide, and one school of fish, without actually hitting the other fish, has its movement transferred into the other fish. So they tend to go in the direction that the fish were swimming. So whatever direction they're coming from, it adds that more direction to the other fish. So the one school transfers its directionality of its fish onto the other fish. So they're just transferring direction. They're not transferring energy. Because a fish, there's no half a fish. The fish can't be a half a fish. Alright, so anyway. So the other thing I wanted to talk about related to the two slips, I guess I can draw a picture of this. I mean, I guess I could have drawn a picture of the fish gravity thing, but I think you understand what I'm saying, that it's not classical pressure. And see, that's the danger of using these words. People use these words to describe something that's working on a different level. It doesn't, the mechanics aren't in a medium. They're functioning purely kinetically at the atomic level, subatomic level. And it's only on the atomic level, or the bigger level, that you have these transfers of vibrations and other kinds of shaped behavior, nuanced school behavior. So the school is vibrating, and it can transfer the vibration to another school. And that's very different from the internal dynamics, what the individual fish are doing. What the school is doing is obeying different rules than what the individual fish are doing. That's not quite right either. Because the only rules that exist are on the individual fish level. Those are the only rules. And it just looks like there's something else happening. But there isn't. It's just a transfer of direction. There's no such thing as energy. There's just direction. Well, okay, so you guys got to be so careful. Because again, it's the two worlds are very different. It's very different when you do something in a medium where the action can dissipate through a medium, and when you do something where you have to remember that when a photon goes into matter, that movement of that photon, if it doesn't go out the other side, or doesn't go out somewhere, if that photon doesn't leave, it is going to be bouncing around in there, frictionless, forever, until it leaves. Its energy is in there till it leaves. It's just stored. It's just caught in a pattern. Yeah. But that pattern has to account for the initial directionality. So its initial direction will have to be somehow transferred either in the behavior of the thing that traps it, has to move in that direction of Planck constant, or it has to release that directionality in that direction. So it either has to absorb the direction, send something out in another direction, or send something out in the direction it was going. And if it sends it out in a different direction, it has to, the other photons have to change their direction to account for it. So it's like there's an exchange. Piro would talk about information. The only information anything carries is direction, and there's always an exchange of directional information. There's no other kind of information. And again, as I pointed out, in some exchanges, there's no exchange of any information. When two photons theoretically collide directly with each other, they just go right through each other. Even if those photons are in an electron. That's one of the rules. Because it's purely kinetic. And yeah, okay, yeah, we have to watch the previous videos to get any of this stuff, right? Because this is just, you know, it's not very complicated, but it's physics. Fuck, it's a little complicated. But again, this is my, you know, somebody's critiquing me here. Are these not the same tactics as create tards, ID people who just go around trying to poke holes in someone else's arguments? Well, that's exactly my point. You're arguing that I'm somehow, well, I'll read the rest of this, being offensive to the icons. The icons are guilty of exactly this. You know, Feynman said this theory was no good, and he said it was no good for invalid reasons, for reasons where he wasn't accounting for the fact that, yeah, it's not a medium. There is no transfer of energy. Photons don't do that. Photons do not transfer energy with each other. They only transfer direction. And they do it without losing any energy. Photons do one thing. They move from point A to point B at the speed of light, and they never stop doing that. They just change where the point B is. They hit something, that becomes point A, and then they go to point B, the new point B. But that's all they ever do. They don't do anything else. They don't transfer anything else but direction. Yeah, something like that. Without making an actual argument in response. So again, this is what you would draw. You would say this isn't an actual explanation or an actual argument. Come on. Theorizing is all well and good, but until the math and tests are done, isn't it a bit over the top to be so confident you are right? Well, my point is I don't have to do the math because the math, I'm not, my model fits the existing math. There's nothing about what I'm saying that is in conflict with the math. The math that makes quantum theory make sense is a math of, you know, for example, in the two-slit experiment, is a math of just recognizing the distance, the thickness of the slit, okay, and then the wavelength of the light, and the distance to the target. All of those factors are, in my theory, just the same. I'm saying the distance of the thickness of the slit is critically important to the vibration of the atoms in the slit, and that they're the ones, those electrons on the surface, are the things creating the phenomenon. So I'll explain that. I'll get to that. All right. A little bit of humility goes a long way. Well, again, you know, that would have been nice if some of these people would have offered that same humility to the things they destroyed recklessly and sloppily. So where's their humility? They seem to want to jump on their bandwagon, and they seem to be trying to sabotage any other bandwagon. So they seem to be in their business just as much as I'm in my business. I'm saying I have a model, okay, that not only accounts for time dilation, not only unifies gravity, magnetism, what's the other one? Energy, whatever the other one is. You know, it accounts for all. It accounts for what holds atoms together and what creates all the other phenomenon we see in material action. It does what Einstein was trying to do. It unifies it all. It creates one force, okay, and it just changes, modifies it slightly to create all phenomenon, including, like I said, time dilation, which is really just recognizing that when you move matter, the patterns that the matter was making is now, those patterns have to change. They have to slow down to be able to account for the movement, because it's all on a checkerboard. And so if you have something doing stuff on a checkerboard, making a figure eight, and you force the figure eight to move sideways, the figure eight will be made slower. See, so it accounts for the math that already exists. So I don't have to do new math. And I don't think I'd want to do some of the math they're doing because it's obtuse. Okay, it's made out of unreal numbers. It's made out of catch-22 style constants, and you know, very convoluted ways of doing something like multiplying something times itself upside down. doing some sort of trick. Okay, it's more magic than math. It's, shoving doves up your sleeve and then saying, look, I did math. No, that's a contrived formula, okay, that merely randomizes a number. And that's all it does. It doesn't do anything special. It just accounts for time. Accounting for time in a mathematical equation is a little bit complicated. Well, anyway, I don't even get into that. I don't even get I mean, again, do you want to strangle me because of the math? I'm just going to say to you, go back to Newton. He was 98% right. There, that math is consistent. I'm consistent with 98% of Newton. I'm saying whatever missing pieces might exist, and I don't think they exist. Yeah, let mathematicians do it, okay? That's what Einstein was allowed to do. He wasn't forced to do all of the math himself. Anyway, a little bit of humility goes a long way when standing on the shoulders of giants. Well, like I said, I don't think I'm standing on any shoulders. That's the whole point here. All right, I mean, I came up with this theory. I came up with the idea that I think there's another answer. And so I went thinking on what the other answer would be for gravity. And an obvious thought came to me that, yeah, it's kind of like rain. It just pushes. Everything looks like it's getting pushed. The idea of pull doesn't seem to make any sense. And the idea of push seems to make sense. And so then I came up with a way that push is possible. All right, and I found out it's pretty much the same theory that some guy came up with, the whatever, 150 years ago, 200 years ago, and they discounted it because they weren't thinking about the fact that photons don't transfer energy. Photons don't transfer energy unless they interact with an electron. They can't transfer energy individually interacting in space with another photon, for example. They can't transfer energy. They can only transfer direction. Okay. So screw you, asshole. And what's your icon? What is this? Firefox on fire? I don't even know what this phantasmagorical crap is, so you look like you have an agenda anyway. So anyway, standing on the shoulders of giants that came before you, just slap them in the face. Well, again, I don't think I'm standing on their shoulders. I think I have done the thought put work. I've spent 5 years thinking about this. And so I don't accept your critique. I don't accept. I find it offensive to argue that I'm not making actual arguments. I think I am making very valid actual arguments, and what I'm not getting back is any actual counter argument beyond you can't dispute Einstein. They're the shoulders of giants. They're infallible. Feynman is infallible. It should have been his middle name, right? Figman Infallible Feynman or something. He should be a Disney character. Well, I don't think it was infallible. Alright, so anyway, getting to the photon question. I don't know if it's related to this superior mind guy who I often find annoying. So being that the unit constituents accumulate and are bound by the rules of single movement divided by t0, making it consequentially require more exchanges to accelerate the limit. So again, what I'm saying is thus mass momentum. Well, I'm saying that mass and momentum are just a phenomenon of school dynamics, but that there actually is no mass and momentum. The individual fish are massless and momentumless, okay, in the sense that they only have momentum in one direction. And the point is that when the photons are trapped in atoms, then they're multi-directional. They're moving in many, 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 many directions. And so, like the school of fish, they're stuck in patterns. Alright? And they can just do that forever. But if there's a slight change in the disposition, that change is kept, and that's called momentum. So if you change the pattern slightly where they take one more step this way than they were taking this way, so if their figure 8 is lopsided in a direction, they'll end up moving in that direction. So if the figure eight isn't an even figure eight, but it's a lopsided figure eight, then they will tend to move in the direction of that lopsidedness, or that ellipse. So that's again another explanation of this whole, the ellipses that end up in the solar system, because of the tug of the planets with each other, but I think predominantly because of the tug of the sun on the planets. I mean the galaxy, the thing holding the Earth. I mean, the thing holding the sun in its place is also affecting the Earth in its movement, just as the moon is being affected by the sun in its movement. Anytime you have a differential in your profile to something shadowing gravity, as you move your distance forward or closer to that thing having a shadowing gravity, it will change the pressure. There's more pressure as you get closer. Inverse square rule. Okay, so anyway, doing the two slit bit, I'll just get to that. This guy said some decent things. He says there's reasonable explanations, blah blah blah. I don't know if there's a quantum thing in here. Well, anyway, I just want to get to this point just because there's a... So what I'm arguing is that the entire phenomenon of the wave, light does not have a wave function. It doesn't have a magnetic component. Light is not this thing. Okay, this wavy crap is what happens when photons interact with atoms or electrons. The atoms and electrons are waved, are moved, are vibrated by the interaction with the photon. The photon changes the direction of the atom or electron, which creates the illusion of wave as being what's happening when these interactions are happening. But the interactions have no analog wave character. It's entirely digital from the photon's perspective. Photons hit things, things move. Photons get stuck to another photon in an orbit, and that's what they do. They just orbit. They're lost for a while. But obviously what I'm saying is that electron can have a shape to its orbit, and any ellipticalness to its orbit is going to create directionality in its tendency to move. So any ellipse in a orbit is going to create directionality. So what I'm arguing, okay, is that in the two-slit experiment, photons are just doing the point A to point B thing. Okay, that's all they're doing, straight line. And they encounter these slits, and what's happening is it's calculated, these distances are calculated that to maximize interaction with surfaces. So these two surfaces, okay, are connected to larger material structure, so that's like a thick piece of glass, and then there's this thin bit of matter in between that is going to vibrate different than these big. So you can understand that obviously the slit is going to vibrate at a different frequency than the big things. So it's like tuning forks. If you look at tuning forks, you know, they get thinner and thinner, and that's what they do. Okay, so this is the low frequency and this is the high frequency, and it's just obvious that that's the correlation I'm making here. Is all matter's vibrating, and it will vibrate at a frequency related to the density, let's just call it, or the mass. Okay, density or mass will dictate the vibration, or mass per oh dear. I mean, obviously there's probably a word for a section. You know, a word that accounts for mass per thickness. I don't know. I don't know what that would be, but there's probably some sort of scientific term for that, but I don't know what it would be. So anyway, what's happening, in my opinion, so anyway, the math is, for quantum mechanics, is basically just saying, look, we take this distance, and then we just assume the photon went through both slits, and so then we create a triangle to a point, and what we have is a difference, okay, in the wavelength, and then we're going to sit there and add and subtract the wavelength, the period, the phase. So now we're just going to do a phase subtraction to say how intense the light's going to be in any one location. Well, that algorithm is exactly this. It's using the same components that I would be using to make the argument that yes, here's the way. So the wavelength of the light is one of the variables that goes into this math. Okay, the thickness. So you got the wavelength of the light, you got the thickness of this middle post. So you got PT. Okay, and then you have the width of the slits. So WS, and then you got the distance to the target. And so those are the variables. And what I'm arguing is that, yeah, these variables are also going to be, it's not about just phase differences, but I'm just saying that it's the same variables. It's the same variables I'm contending are creating the phenomenon, but it's doing it based on what the electrons are doing it. So now I'm sort of, man, that's a weird looking bubble. You see that? I see a bubble in there. Anyway, fisheye. Fisheye bubble. That's interesting. Anyway, all right. So what I'm arguing, just redraw the image, is that yes, it's these vibrations that have a period to them. A timing cycle. So and that photons are 2 photons. Okay, a photon of light is made of 2 photons. It has a frequency, and the only way you can have a frequency is there has to be 2 of them. And so what I'm arguing maybe, okay, and this is just an explanation. I'm just saying we don't quite understand how, when light is absorbed by an electron, how it releases it at exactly the same, at the appropriate angle. So it goes in one angle, it comes out at the appropriate reflective angle. So it doesn't bounce off the atom. It's absorbed and readmitted at the appropriate angle. And how exactly that mechanism works, we really don't know. But this is what would force something to fit into the rules of this frequency, is the fact that however it's interacting. So let's just remember this. So this is vibrating, and this whole surface there's electrons on both sides of this slit, right? So there's active electrons on both sides of this slit that the light is likely to encounter. It's going to be hard. Most photons will not go directly through the center of the slits from either side, and especially when they're coming from a single focus here in the back. So they're coming from a single aperture. The odds of them being able to get through these slits without coming in close contact with this material is very low. So it'd have to be exactly right in the right center to avoid what may be very aggressive electron density on these surfaces. So I think you can understand that if I argue that all surfaces have an electron density around them, that's not an unreasonable statement. They all have a static charge, so to speak, and that static charge is basically made up of photons and a density of electrons. Right. So the odds of these encounters with electrons are very high. And so when it encounters an electron, what I'm arguing is happening is the electron has a frequency that it's vibrating at. So it's vibrating at a frequency. And that frequency is going to be transferred to this period. Okay, so there's a period to the photon that's coming in contact with the frequency of the electron. So the electron will only be in this position for a certain number of seconds. If we called it 10 seconds, it might be 2 seconds here, it might be 1 second here, it might be 4 seconds here, let's go 2, 4, 8. So these are the numbers, right? So it's not moving because it has to, so to speak, okay, like all objects. You can understand that all objects, to be able to change direction. If I'm going back and forth and I'm in a frictionless environment, what's going to happen is I go to a certain peak acceleration, and then I have to start slowing down before I get to the stop point. Then I stop, then I have to speed up again, get to a maximum speed, then slow down again and stop again and then bounce back. So there's no consistent velocity involved in these vibrations. So even though this looks like a consistent velocity, on the atomic scale it probably isn't. And the same argument would go for how atoms move. They don't move in some going the same speed all the way to the stop point and then go the same speed back here. They're moving at different speeds and different accelerations, which means they spend a different amount of time in certain positions. So they spend more time in the maximum position, the farthest out they move. They spend more time out there because they had to do the slowing down and now they have to do the speeding up. So they're going to spend more time in that quarter of their cycle, and in the far end part of the all the way to the left or all the way to the right, those two cycles will be the longest period of time. They'll spend the least amount of time in these two center pieces, and they'll spend a medium amount of time in the middle. And that's the phenomenon that's generating the transfer of that pattern onto the photon. And let's understand that now we have this complication of the photon having a period itself. So when it interacts with an atom, it's going to have some sort of period problem, because this atom is going to, say the first photon comes in and it's at peak position, the electron is going to start moving in before the period of the photon is complete, which means the second photon is coming through and it's going to be at a different position. And so now these two photons have now changed their position, because the first one was moving this way and now the second one's going to be slightly off of that this way. So the period remains the same, but the pair of photons are now moving this way like a parallel. So they're still close to each other. This period might be a very small, I'm drawing it very big, but this distance might be incredibly small, a portion of the period. So it might be 10% of the period, it might be 1/100th of a percentage of the period, but it's going to be something. So now the photon has essentially got its rear end swung out like a car that's going around a curve, and the rear end swings out. The car is still going this way, but its butt end is in the wrong direction. So now its movement, the directionality is going to be a compromise between those two movements, let's say. It's when it finally hits a target, it's now been changed in terms of its angular momentum. Its angular direction was changed by this interaction because there was some drag, and now the swung out new direction is slightly off of this, what we would expect the pure reflexive angle to be. So it's not going to have a clean reflex, because this object has moved while it is interacting with it. Something like that. So anyway, I don't think I even need that part. I just need the idea that the math is entirely made up of these variables, and these variables are completely understandable as all being controlled by electrons that are likely doing different things. The electrons here are likely different than the electrons here and the electrons here, and clearly the electrons of this, like when the right slit, when an electron is going this way on the right slit, an electron is likely going the opposite way on this side of the slit. So they're going to be inverses of each other. Which probably isn't important. It's hard to say. I mean, I'm just going. I haven't seen any. You really have to do these experiments. You have to have them in front of you so you can dissect them, and we really don't have the experiments in front of us to dissect. But they say they can send single photons through this experiment and get this result. In that sense, a single photon going through one side of the slit or the other side wouldn't make any difference if one was left and one was right, because it's not about the slits anymore. It's just about the fact that there's a distance between them, and what the image really is just a mirror of the slits. It's an image of the slit. So what's really happening, I guess what I would really argue, is that all you're getting is mirror images of the center pedestal. So all the dead spaces on the pattern are just being created because it's creating an image of the center impediment. You're seeing the center impediment, and it's creating images at the wavelength of the electrons. So the vibration of the electrons is causing the image to be diffracted at consistent levels that are consistent with this pattern I was talking about, this idea that it spends twice as much time, the electron spends twice as, as it's vibrating, it spends twice as much time on this part of its cycle and this part of its cycle than it does this center part of its cycle. If 4 times as much, twice as much for each quarter, so 4 times as much as for the whole circle. It's squared. It's twice as much for each individual one, but if you think of both sides and think about it in comparison to the middle, well, yeah, then it's cubed, or 4 times as much. I'm cubed, 4 times as much. Right. Which is 2 things squared, I think. Well, I don't want to get into the squaring versus timesing. Because, yeah, sometimes they're the same number and sometimes they're not. And that's sometimes really significant. But anyway, I don't know if you could follow that. But I'm just saying that the idea is that the vibrations, the things that look like waves, the stuff going back and forth, that's the wave. That's what the electrons are doing. That's not what the photons are doing. And every time we see a photon, we see it as it interacts with something that is moving. There's no way for us to see a photon by let it bang into something. Well, it can't bang into something that's not moving. It's just not possible. It's all moving. And I mean, this might explain some of these phenomena with the super cold magnetic fields and such, because yeah, some of this photonic behavior might substantially change as you get things cold enough where they're not vibrating anymore. You might lose all this quantum crap, and that appears to be true. So anyway, that's enough of the video, I believe. So anyway, I'll try to do some more of this. I just haven't had time, but I just wanted to get to this. The wavelength of the light is important, I think, clearly, and understanding that electrons are vibrating at a wavelength themselves is also important. Many wavelengths. Okay, so until next time.